అందరికీ నమస్కారములు. గురుభ్యో నమః. నమో నమః. Today is another good day that we are going to have another good session from Gautham Mukherjee ji on Vedic mathematics. Today is the fourth day of our classes. Let us start the session with Vande Mataram from Challa Chittibabu garu. Please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram vande mataram. Vande Mataram. Namaskar.
వందే మాతరం. ధన్యవాదములండి చల్లా చిట్బాబు గారు. Now let us request Funny Praveen to chant Prarthana, please.
Om Gananam Tva Ganapatikum Havamahe Kavim Kavinam Upamasravastamam Jeshtarajam Brahmanam Brahmanaspatana Sadhanam. Om Sri Mahaganathipataye Namaha. Saraswati Vinivati Dinamavitriyavatu. Om Sri Mahasaraswatye Namaha. Gurureva Gati Gurumeva Bhaje. Gurunaiva Sahasmi Namo Gurave. Na Guru Paramam Sisurosmi Guru. Matirasti Guru Mam Pahi Guru. Jnananandamayan devam nirmalaspatikakrutim adharam sarva vidyanam hayagreevamupasmahe shruti smruti puranana malayam karunalayam namami bhagavat pada sankaram loka sankaram Sankaram Sankaracharyam Kesavam Badarayanam Sutra Bhashya Krutau Vande Bhagavantau Punah Punaha Iswaro Gururatmeti Murti Bheda Vibhagine Vyoma Vadvyapta Dehaya Dakshinamurtaye Namaha Asato Ma Sadgamaya Tamaso ma jyotirgamaya mrutyurmamrutangamaya. Om Shanti Shanti Shanti. Matrudevo Bhava Pitrudevo Bhava Acharya Devo Bhava Atithi Devo Bhava. Om Sahana Vavatu Sahanau Bhunaktu Sahaviryam Karavavahai Tejasvinavadvitamastu Ma Vidvishavahai. Om Shanti Shanti Shanti.
Okay. ధన్యవాదములండి ఫన్నీ ప్రవీణ్ గారు. యువర్ ఇంటర్నెట్ కనెక్షన్ లుకింగ్ టు బి లిటిల్ వీక్ అండ్ okay, let us request Gautham ji to start the session, please. 1 minute. Okay.
Namaskar Rahul. Rabika Namaskar. So I start my host disabled participant screen sharing. So can you enable my sharing?
Yeah.
Actually, we completed the multiplication division. Today mainly we will focus on recurring decimal. Now let me share this. So yesterday I started the session that I started it that from the current slide. Sorry, the division where we stopped with the quotient and remainder, we can continue it, and then we found that it becomes a whole part as well as a fraction of the form n by d. Now numerator by denominator, that remainder becomes my numerator, and denominator is the divisor become denominator. Now I told that any rational fraction uh, of only comprising powers of 2 and 5, because those are my components of our base, that is 10. So that it becomes a terminating decimal with length equivalent to the maximum power between 2 and 5. Whichever power is maximum, that becomes, or both can be same. Say here, both are 2 here, 2 square into 5 square. So that length will be that maximum power of between 2 and 5. Here 2 cube is there, so 3 decimal is there. Now, when in a fraction, decimal fraction, whose denominator ends in 1, 3, 7, or 9, it becomes a purely recurring decimal. Today, basically, we will cover this. And whenever this is very simple, there is no problem. Even somebody has to suppose someone wants to calculate 3 by 8, then even one can suppose this one, 1 by 25, something by 25. There is no problem here because uh, uh, multiply both numerator and denominator by 4, and then you get this automatically. We get and change the decimal point to two points towards left, and then you get the result. Like 1 by 125 will be easily found out. Uh, Multiply by 8 both numerator and denominator, it becomes 0.008. That way, these are very trivial, so we do not discuss this part. This can be by any method you can do. This is the one, the recurring decimal. This needs some attention. This becomes a lengthy at times because the recurring, say 1 by 19 has 18 digits. So this becomes a very lengthy process. So we do not, we follow a particular procedure called one-line method, Vedic one-line method. We will discuss it. And obviously this one, any fraction of this form that other than these two part, purely 2 power of 2 or purely 1379, ending with 1379, these actually will have two components. So we can separately we can calculate, and then you can do this thing. If we do not want to use the conventional method, we can club this terminating decimal and this recurring decimal in the type 1 and 2 discussed. So that can be done. So we do not separately discuss this one also. And this we of course discuss the decimal form to rational form, what to do. That we can again try some of them, and you can get the idea. Now, in conventional method or Nichilam method, I have shown that how say 30 divided by 8, you can continue with, like we continued in the conventional method with a 0, and then put a decimal point and put a 0, and say here also it can be done like 30. We are dividing by 30, you are dividing by 8. So we know that it is 2 deficient, so 3 into 2 is 6, and it becomes 3 and 6. 3 is my 3 was my quotient, and 6 was remainder. But if you do not want to stop there, with 6 again we do the same thing. You put a 0 there, and then again 6 into 2 is 12. So it becomes this 12. 1 actually contributes towards, because it is more than this. So 1 contributes here. It becomes 7 and 4. Because 12 minus 8 is 4. That 1 is contributed here, and 4 becomes. So 7 becomes my 3.7, and then 4 again remains. So that 4 we continue with another 0, and then again 4 into 2 is 8. It becomes 8 into 0, and finally becomes 5 and 0. So it becomes 3.75. Further we cannot do because everything is 0. So this is the way earlier also did our way. So I am showing that by Nikhilan method also you can do that. But I have shown that how 22 by 7 we can arrive at, and 3.1412, that we know it, 1412857. It repeats. So this can be done like in conventional method as well as this method. And I have shown another one. It is 21313 divided by 89. So can be done, and when it is done, so quotient becomes 239 and remainder becomes 42. So this 42 we can do like this, and this we can arrive at this one and this one. But what I'm telling is that the I'll discuss it later. I told somewhere that after this is Nikhilan method. You put a decimal point and quotient and 0, and the remainder continues like that, like we do in conventional method. However, the process may become long in Nikhilan and conventional method alike. These are very cumbersome, and we do not go by this one. Rather, what we do, we're calculating a fraction like 1 by 19, 2 by 19, 1 by 1 by 29, 1 by 49. Are quite long and cumbersome both in conventional division method and Nikhilan method. Vedic one-line method arising from the Sutra Ekadikanu Purveno is easy, having more than one ways, and it reveals further properties of the fraction, such as cyclic property and nines complement behavior. All the different behaviors, sometimes you see that these kind of behaviors are discussed, but they didn't discuss what is the origin of that behavior. Basic online method is directly applicable to denominators ending in 9. This is very important you do, so that other endings, so 1379 I told, if it is ending in 137 instead of 9, so what to do, that those things should be discussed. So currently we start the discussion of the method with ending in 9, and especially 19 we start with, and 1 by 19. Now, if we do 1 by 19, we know actually. So, what I show you that. Now, if we do 1 by 19. So, suppose I do 1 and 19 here. So nothing goes there. So I put a decimal point, put a 0. And again, it cannot be there fitted. So we put another 0. 0 and then 5. It becomes 95. Then 5 and 0. It becomes 2, 38. This way it goes actually, you know. And then another 0 here. So 6, 1, 1, 4. So it will be have 18 steps. It will be very big, like this. It will be big. And imagine somebody is asked to do, say, 1 by 19, then 2 by 19, and up to say all dots up to 18 by 9. There are 18 factors possible, which denominator as 18 factors possible. So all these will be separately has to be done, and all will be very lengthy. So imagine the situation. Now, here I discuss the procedure. Next one, next slide. Now, it is telling that instead of dividing 1 by 19, we shall start dividing 1 by a digit divisor. Now it will be called digit divisor. Every digit will be divided separately. DD, which is D plus 1 by 10 or 2. Or you can do Ekajikono Purveno, means that what is Purveno? Purveno of 19 is 1. We simply do 1 plus 1. Ekajikono means more than 1, so it is 2. So we divide by 2. So this is, both way I have shown that whole formula and this one. Put the decimal point. I am putting the decimal. So 0 point I put here like this. Put the decimal point. Now I divide 1 by 2. 1 is divided by 2. It gives a, normally when I ask anybody 1 divided by 2, say they'll say 0.5 in there. Don't jump to 0.5. 1 divided by 2 in the quotient and remainder format will be, quotient will be 0 and remainder 1. So this you have to be taken. This is the, sometimes people feel a jerk there, that immediately they say 0.5. 0.5 I don't want. I want 0 quotient and 1 remainder. We write like this. Okay. Now this is looking like, when I write this form, this is looking like 10. That means that it is actually, this remainder will be used as a tens digit. So it becomes a 10. So I divide again by 2. Digit divisor constantly will divide by 2 only. So 1 0 becomes 5. Okay. 10 divided by 2 is 5. There's no remainder. So I can put a 0, or I may not put a 0. I can may not I keep it. This is I may not keep it. Like I'm doing it again. Like I put here. So 1 was my quotient and sorry, 0.0 was my quotient and 1 was the remainder. I put simply divide by 2 and we put 5 here. Now 5 we divide by 2, it becomes 2 becomes my quotient and 1 becomes my becomes my remainder. So here it is 12, looking like 12. So 12 I divide by 2, it becomes 6. 6 we divide by 2, it becomes 3. Without the remainder, do not write the remainder. You can write also, it is your choice. 3 divided by 2, it becomes 1 and 1. 1 quotient, 1 remainder. Again, this is divided by 2, 5 becomes my quotient and 1 remainder. Okay? You understand how it goes? Any reaction? Any problem? Now 15. 7 becomes my quotient and 1 becomes my remainder. 17. 8 becomes my quotient and 1 becomes my remainder. Now 18 by 2 again. So 9 becomes my quotient, no remainder. So this way it goes. I have written here. So this will be my, if we use the calculator, find that these are the first initial 10 digits, it will show that, but it will, calculator or even Excel sheet will not show all the 18 digits. Now it is 9 divided by 4, it becomes 4. Moreover, actually, there is another way I'll discuss it. It is the same one. You subtract, after this, there are 9 digits. You put a dot here. And you can subtract from 9. So this is becomes my 9, 4, 7, 3, 6, 8, 4, 2, and 1. It ends in 1. So this 18 digits, 9 plus 9, this 9 actually, that means it will continue like this, 9, 4, 7, 3, 6. And remainder will be adding to 1. This 2 minus 1 is 0, 0, 1, again 0. This is 1, 1, like that way. Remainder also can be found out, and that way it will continue. In the next slide, I'll be discussing it. successive quotient Q and remainder in the form this one. Q written, R written, remainder written slightly below, down, left, are the follows. From the beginning of 1 by 19, remainders are written left in small, 0 point, this 0, 1, 5, 0, 2, 1. I put the remainder here, 0. So it will be putting, and then as I told, if you cut it halfway, if you know that it is for 19, you may not evaluate, you just subtract from 9, and the remainder also subtract from 2, subtract from 1. Both will be adding to 1. So wherever there is a 1 here, it will be corresponding 0, and it will be 0, 0 is there, it will be 1. And it is 0, so it is 9 minus 0 is 9, 9 minus 5 is 4, 9 minus 2 is 7, and that way. You can continue that also. 18 by 2 is 9, 9 divided by 2 is this 4 and 1. Again, 14 divided by 2 is 7, 7 becomes 3 quotient, 1 remainder. 7 divided by 2, 13 divided by 2 becomes 66 quotient, 1 remainder, and that way it goes, and this way. Not only that, you can also do from right to left. Since you have done 1 divided by 19, you start with 1, and 1 into multiplied by 2, and then 2 multiplied by 2, 4, 4 into 2, 8, 8 into 2 is 16, 6 you put and 1 as a carry. 6 into 1, 6 into 2 plus 1, 13. 3 put here, 1 put here. 3 into 2 plus 1 is 7. 7 into 2 is 14. 4 into 1 plus, that way it goes. In various ways you can do. I've discussed all these things here. Now, any reaction? Learning the method?
So I think they are not muted, unmuted. So
no, it's unmuted. Sir, if you could explain this one more time.
Once more?
I'll unmute. Anyone who wants to say something should raise their hand digitally so that I can unmute and they can talk. Otherwise, we move forward. Anyone who wants to say something or say whether they have understood or not? They want a repetition? Right. Tell me, Pantulu garu.
Sir, please repeat this 1 by 19, sir.
Yeah.
1 minute. I'll repeat from the beginning.
Right.
And repeat with this particular one, this particular slide. See, this one, I'm instead of dividing by my dot is instead of dividing 1 by 19, we divide 1 by 2, but in a quotient and remainder format. So first step is 1 divided by 2 in a special fashion. We put it like this one, and it is not equal to, but it is special fashion. I use this notation, 0 point in the quotient and remainder format. When we divide 1 by 2, do you have any confusion? That quotient will be 0 and remainder will be 1. Because what? Because you know that quotient into quotient multiplied by the quotient multiplied by the divisor plus remainder is my dividend. Okay, so it should have been 1. So what is the quotient and q into 2? So what is the something into 2 plus r? This 0 into 2 plus 1. The 1 is 1. So this, therefore 0 is quotient, 1 is remainder. There should not be any confusion. Now it is looking like 10. So we divide by 2. So 5. This remainder will be used as a tens digit. Now 5 we divide by 2, it becomes 2 quotient and 1 remainder. And it becomes 12, looking like 12, so divide by 2. That way I have shown here. 0, 1 and 0, then divide by 2 is 5 and 0. Then again, this becomes 5, 2 quotient, 1 remainder, because looking like 12. This becomes 6, 6 divided by 3. 3 divided by 2 is 1 quotient, 1 remainder. And again, 11, 5 quotient, 1 remainder. In 15, 7 quotient, 1 remainder. It becomes 17, 8 quotient, 1 remainder. Then it 9, 9, 0 quotient. 4 quotient, 1 remainder. 14, it becomes 7. 7, 3 quotient, 1 remainder. Okay, 13, 6 quotient, 1 remainder. 16, so it becomes 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. When we arrive at 1, we started with 1, we arrived at 1. That means we put a dot and we put a dot. Actually, this didn't come. Actually, 1 by 19 is this one here. It will repeat 0, 5, 2, 6, 3, 1, 5. Now it is clear? Well, okay, we'll give more example and then you will find it. Now, with this one, the very peculiar thing. Actually, earlier we did it. I've shown that suppose somebody has to do 1 by 19 to 18 by 19, all the fractions, one has to do it separately. But here we find, suppose we want what by 19? Anybody asks which by 19 should I do? Can speak.
2 by 19, sir.
2 by 19. So what is 2? You have to search 2. Search 2. 2 is my 2 is here, isn't it? Is here. So had I gotten 2, I would have divided by it by 2. So it is 1 quotient and 0 remainder again. So it will be 0.105, like 2 by 19 will be 0.1, and then again we'll rotate it 0.5, 2, 6, 3, like this. What else you want? Suppose you want 18 by 19. 18 by 19. 18 is here. See, it is here, 18. Had we got 18, we would have divided by 2. So we write it 0.094. 18 by 19 will be sorry, not 0.94736842152631578, like this. It will rotate actually completely, a complete full cycle. It will go like this. Wherever you do it, it will go again, because it's actually repeating. No, it is actually repeating. So suppose say 11 by 19 you want. 11, everything is there in this line only. 11 by 19, it is 0.5789473684215263 1, ending in 1. 11, we started with 1, it is ending in 1, so it is also ending in 1. And we have to put this one and this one after writing that straight. Done now? So it is interesting, this method?
See, yeah, okay, Martin.
Sir, I think
In
this
case of full cycle.
This what the result we got from 1 by 19 is the base for all the other formula, all the other equations like ending divided with 19. This is the base one.
Right.
Am I right, sir?
Base?
This what we got this result now.
Huh.
This 0.100512 is the base for all the problems which are to be divided by 19.
Yeah. So
This
take your calculator and verify that what you're getting. Start. You say I say 7 by 19. You say please use your calculator and find 7 by 19 just now? Did you do 7 by 19?
1 minute, sir. I am doing, sir.
What is the result?
Zero 0.36842.
Yes. See, 368,421 and then 0.5263. Isn't it? Calculator will not display all the digits. It will display only, I think, 10 maximum, something like 10. It doesn't do more than 10. Up to what you displaying?
So
36842.
Sir, excuse me, sir. Sir, this is 7 by 19 because 7 is coming here in this one. After that, all the digits 3, 6, 8, 4, 2, 1, again 0, 5, 2, 6, 3. Up to that is what this calculator is also showing the same numbers.
Yes, same numbers. That's what I'm telling. With this single line, it is the answer for all the fractions 1 by 19 to 18 by 19. You have to start with the proper fashion. Like this is the cyclic property, and then, as I told, wherever this is the dividing line. This is the 9's complement property. This is full cycle like this. Digits are from a half length, 9's complement of digits and of the other half length. Thus, after evaluating 9 digits, we could have gotten the rest by subtracting them from 9. Please see above. Please note, corresponding remainders are added to 1. That means DD minus 1. Digit divisor DD was 1. Digit DD was 2. So 2 minus 1 is 1. So all the corresponding remainders can be added to 1. However, there is, if you write it below, you will find that this 0 and 9, 5 and 4, this pair is there. But here the remainder was 0 in case of 5. Here in case of 4, it is 1. So that way, I'll proceed and I will do for this thing. Method of one-line method, case n by 19. Anything n. So since the denominator 9, we get a full cycle. It is full cycle means 19 minus 1, 18 digits. Full cycle, it is very easy to get the result from other numerators. For example, I'm just discussing again. In case of 9 by 19, the starting digit is 9, and we can follow the same procedure as previous, either division to left, right to right, or multiplication for right to left. Since we know the sequence 0.05263 and so on, along with remainder already, just by observation below column, we get 9 by 19 is equal to that 0.47 things here. And the sequence is same, but starting point is different. And check also 9 complement. 9's complement is there. 4 plus 5. Here 4 plus 5 is 4 plus 5 is 9. 7 plus 2 is 9. The same thing, of course. This is the same cycle is used. Now guess for all these things. Now you can guess later. Now we come to the next slide, which is 1 by 29. So the denominator is 9. The digit divisor will be 1 more than the previous. So previous of 9 is 2, and it is 1 more than 3. Also these things, so 3. In case of 29, this digit divisor is 3. 1 divided by 3, quotient is 0 and remainder is 1. It becomes always like that. And it becomes 10. 10 divided by 3 is quotient 3 and remainder 1. So 13 by 4 it becomes like this, 4 and this 13 divided by 1 by 4, and we successfully QR combination, and becomes 1 by 29 becomes first with 0 and 1, then 3 and 1. This divided by 3 is 3 quotient, 1 remainder. 13 divided by 3, 4 quotient, 1 remainder. Again 14 divided by 3, 4 quotient, 2 remainder. 24 divided by 3, 8 quotient, 0 remainder. So that way it goes, and finally, actually full cycle here is 28. This 29 minus 1, 28. So it is actually 28 digit. And again, the same thing is there. Suppose you want, which you want, what by 29? Suppose you do 18 by 29 you want. It will be how much? You can try by calculator also. It will be 0.62068965. Here after 28 divided by 2 means 14. 20 by 2 is 14. So after 14 digits, I put it on a separate line. So you see that 0 plus 9 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 4 plus 5, 8 plus 1, all this is 9. And remainder also, 1 plus 1 is 2. Here, 3 minus 1 is 2. So remainder addition will be 2. 1 plus 1 is 2, 1 plus 1, 1 plus 1, 2 plus 0, 0 plus 2, 2 plus 0, 1 plus 1. All these things, the remainders are adding to 2. And these digits are adding to 9. So that 14 halfway, and this is the full cycle. Like I can put a dot here and a dot here. This is a recurring decimal with 28 digits in case of 29 as numerator. Now all the answers are here, starting from 1 by 19 to 28 by 19. Sorry, 1 by 29 to 28 by 29. All these things are here. So you can try by calculator, any of you try with different digits and verify that it's correct. Say 25 by 29, 0.86206896555147 and so on. It goes back. So can you try yourself? I am coming to white screen. Now I want reaction from others. Suppose I want 4 by 29. What should I do? Somebody asked me to give 4 by 29. What should I do?
One of you should come out and
then only I will confirm that be confirmed that you are learning something.
Yeah, anyone? Yeah, come out, please. Participants, students, they are supposed to come and do it. Who is ready to do it?
Please, somebody volunteer. Somebody don't know. You teach me.
Are you able to listen? Yeah. Who is it? Sujit Kumarji. Yeah. Go ahead.
Okay.
Yeah.
So,
yeah.
What should I do?
So 4 by, if we want to start from the back side, that is
Okay, that's also you can do.
9, 0, 1,
Back side
7.
also can do. Yes, there is multiplication. Yes, you do. You tell me. 4 I write. Then what to do?
So I want 2, 3, 4. So it becomes 7, 9, 3, 1, 0, 3, 4, 4, 8, 2,
How?
7, 4.
No,
It could become, if you do this, take the fourth number from the back side, the sequence should repeat, no?
Yeah.
I think first we should develop the sequence.
Yeah.
4 by 29, in the normal way you do it. Don't go by the sequence is already done. Start 4 by 29, how we'll do? First you do 29 plus 130, that is 3.
Yeah, then 4 by 3.
So 4 by 3 you do.
Yeah, 4 by 3 will be, you get 1. And
No. You should say 0.0. From there you start.
0 point, yes.
Okay.
So you told yes. You told what?
Well, 0.1 with 1 as reminder.
Remainder 1.
Then 11 divided by 3. So that will give you 9, which is 3. and remainder as 2.
3 and 2.
2. And then you will get 23 divided by 3, that is 7, and remainder 2. Then 27 divided by 3 is 9 and remainder 0. Then 9 divided by 3 is 3 and remainder 0. 3 divided by 3 is 1 and remainder 0. Then it will get repeated again.
Huh?
No.
As
You
Yeah.
got only 0, 1, not 1, 1. The start is 1, 1.
Yeah.
Now
Huh.
you
Yeah.
have 0, 1.
So you got
That-
0, 1. Now 0, 1 divided by 3 will be like 10 divided by 3.
No, 0. You put a 0 first.
Okay, you'll put 0
Uh,
and you'll have a remainder 1. Then 10 divided by 3 is 3 and remainder 1.
Why
Then
10?
13.
Why 10?
Remainder is 1. No, 0 with remainder 1. The 0, 1 divided by 3
Yeah.
will be 0 with remainder 1.
1.
So 1, 0 becomes 10 divided by 3 is 3 with remainder 1. And
Yeah.
then the cycle will be then 13 divided by 3 will be 4 with remainder 1. Then 14 divided by 3 will be again 4 with remainder 2. 24 divided by 3 will be 8 with remainder 0. And then 8 divided by 3 will be 2 with remainder 2. And then 22 divided by 3 will be 7 with 7 remainder 1. Then 17 divided by 3 will be 15, 5, remainder 2. Then 25 divided by 3, 25 divided by 24, that's 8, remainder 1. Then 6, remainder 0, 6 to 2, remainder 0. Then 0 2, that is again 0, remainder 2. Then you will come to 0, remainder 2. Then 20. 20 is again 8, remainder 2. 28 is 9, 27, remainder 1. 19 is 6, remainder 1. 16 is 5, remainder 1. 15 is 5, remainder 0. 0, 5. 5 is 1, remainder 2. And 21, that is 7, remainder 0. 0, 7 is 2, remainder 1. 1 to 12 is 4, remainder 0. 4 is 1, remainder 1. 1, remainder 1 is the base again. So we stop here. It repeats after that. It will again repeat. It will again go to 3793103.
You got it like this?
1, yes.
Here also we are getting like this, isn't it?
Series of 9 in that, with the reminders adding to 2.
Reminders adding into 2.
Yes.
This one, huh? Okay, very good. Now, anything divided by 2, any other person, anybody has any confusion, then they can try. Otherwise, we proceed for the...
Sir, once again, you are only explain this 4 by 29. First, starting onwards, please.
Okay. You tell me. You tell.
Let us do another number.
Another number, yes.
Sir,
Let us do another one. Say what? What by 29?
Say 7 by 29.
7 by 29. 0 point. Now tell me. Yes, here.
Yeah, Sunita ji, you do it. You tell how to start. Sunita ji.
Sir, I didn't understand, sir.
No.
Yeah,
See,
acha, let also do it from right to left.
no, first of
Yes.
all, she has not understood.
Now,
Anything.
I'll make her, I'll
Right.
ask her. No,
Okay.
I'll
Right.
ask her.
Fine.
Now, 7 by 29, you start with 7. Okay, now one thing I'll tell you, this, since you didn't understand, I have to work with 3. This 2 is there, before 9 is 2, ekadhik purveno of 9 is 2, 1 ekadhikano, 2 plus 1 is 3. So, you tell me what is 7 into 3, 7 into 3.
7 into 3 means 21.
21. So I put 2 here and 1 here as a carry. Now you multiply these 2 by again 3 and add 1. So what will happen?
6 plus 1 equals 7.
6 plus 1 is 7. Okay. Okay. Now again 7 into 3 is
21.
oh no. Something I'm putting. No. 21. Oh, I'm sorry. I made a mistake. 7. 7 into 3 is 21. So 21, I put 1 and 2 as the carry. Okay. Then you tell me 1 into 3 plus 2. So it becomes how much? 1 into 3 plus 2?
5.
5. 5 multiplied by 3?
15.
15. 15, I put 5 and 1 as my carry, 15. And then we multiply by 3.
15 into 3?
No, 5 into 3 plus 1.
15 plus 1, 16.
16. I put 6 here and 1 here. And again, this 6 into 3 plus 1.
19.
19. 9 I put here. You tell me now what to do.
9 into 3 plus 1. 28.
28. So what to do? What to do? Place where?
8 is here, 2 is
Below.
below.
Then
8 into 3 plus 2. 26. 26. 6 is here, 2 is below.
Then
6 into 3 plus 2. 20. 0 is here, 2 is below. 0 into 3 plus 2. 2. 2 is here, 1 is below.
yeah. Oh, no. Nothing is there. But or 0 is here. I may not put it.
Okay.
So
This is
then
1 into 3 plus 2.
no. There is no 1.
2 into 3.
Okay. 2 into 3. 2 into 3. 6.
Again
6 into 3. 18.
8 we put and 1 below.
1 is below. 8 into 3. 24 plus 1. 25.
Like that was. Okay? 25 is like this. So you got the idea? From the right to left and from left to right, you tell me 7 divided by 3. 7 divided by 3.
2.
2, 1.
3 into 2. 3 into 2 plus 1.
So it is 3 we write and it is now dividing 7 and 3. Okay.
Next, 1 into 3.
No, it is nothing. You are not dividing. This is a dividing procedure. And that was the adding procedure.
I didn't get access.
Oh, I'm sorry. I'm sorry.
It will be 2, no? It will
Ah,
be divided under 1.
2. 3 into 2 plus 1. Then
3 4 is 12. 4.
4. Then
3 1s are 3. 3 1s are 3.
1 1. 1 remainder 1. 3 and 2.
3 and 2.
Madam, sorry, madam, I am disturbing you or following, madam, please.
Oh,
Madam, I am intervening, madam, sorry.
okay. See, 7, we started with 7 divided by 3. Okay. 7 is divided by 3. So 2 into 3 plus 1. So 2 was my quotient, 1 was remainder. Okay. And then it becomes 12. 12, 4 divided by 3. It becomes 4. 4 divided by 3 is 1 quotient, 1 remainder. And then again 11. So 3 quotient, 2 remainder. That way. Okay. Now it is 23. How much?
7 2.
7 and
7 2.
Then
2 and 1.
no, 7 and 2.
Sorry, sir. 72.
27, not 72.
27. 9 and 0. Next 3. 1.
1.
Zero.
When we get 1 for any divisor, if we get 1 for any divisor, it is less than actually something you are dividing which is less than 1, less than that digit divisor, anything we get, always we get quotient 0, mind it. Okay, then next one.
3 1.
3 1.
4 1.
1.
Again 1 1.
14.
Sorry, 14. 3 4 3 4 12 and 2. 24. 3 8 times.
Next.
2 and 2. 3 7 and 1. 7 1. 5 and 5 2.
5 and 2, yes. So
8 and
800. So you understood, no problem. You understood. You become confident. Now see, it is a both way. It is the correct one. See, this way you can do from dividing and quotient and remainder format. You do quotient and remainder like this, Or
Yes.
this way you can do by multiplication it, multiply and then something you write here, a number, second digit, you can say I put it as same thing, second digit and the carry. If there is one unit digits, sorry, I can put unit. And if there is a carry, we put it carry. So this, it is the same thing, Q and R or U and C, unit digit and carry. It is the same thing, both way, ultimately it merges. Is correct? And plus, if we add them, actually 7 should be here. 7 is actually here. 7, 1 is here. This 7, 1 is not there. Here it's not. So here they say 7 plus 2 is 9, 5 plus 4 is 9, 8 plus 1 is 9, 3 plus 6 is 9, 7 plus 2 is, you see 9 plus 0, 3 plus, everything adding to, this is a 14 actually. Here also it is 14 digits, excepting this one, not this one, 14 digits. And here also it is 14 digits. This one, line. These 14 digits and 14 digits, you add up to 9. And the remainder add up to, remainder adds up to 2. 3 minus 1 is 2. So remainders add up to 2. So now I go and, so you understand the whole thing procedure? So you start with 7. You told 7 by 29, so it becomes 2, 4, 1, 3, and so on. Now again you go to n by 29. So I repeat, for 1 by 29, 2, we have started from 1, keeping multiplied by 1 and kept multiplying by 3. We could have started from 1 and kept multiplied by 3 and adding carry to get the right to left method. We see for any, or not only 1, for any number you have just started with 7. We see after half length, we can, the 14 digits, we can corresponding digits, so it becomes 9 complement, also remainder becomes add to 2, d minus 1. For other numerator n, we can simply start with n and keep on dividing by 3. We did all these things and multiply by 3, right to left. So 1 by 29, full cycle, so we get, you can guess for any other number. So you have already done it, so you can just go through. Now we come to n by a9. So far you have done with a is equal to 1 and 2, means 19 and 29. Anything else? For fractions of the form n by a9, we start dividing n by a plus 1. We did already. Ekadhigana Purveno. This Purveno is a, so we start with a by a plus 1 as per rule. Ekadhigana Purveno. In the way that we have illustrated here, and a is the multiple digit. It can be multiple digits, like it can be 12. Say if something you divide by 119, we have to divide by 12. This 11 plus 1 is 12. So here example is there actually using Excel sheet actually. I did 1 by 59. So 1 divided by 6. So for 59, digit divisor is 6. DD. So 1 by 6 is 0 and 1. And when 10 is divided by 6, it is 1 and 4. It becomes 41 and becomes 6 quotient 5 remainder. And that way it goes, and it finally goes up to actually 58 digits are there total. 58 digits, 1 by these things. Here now we come. Now what is the... Now let me do another one. It will be easier, I tell you. It will be easier. 1 by 39 and something by 30. Say 6, not 6. Say 7 by 39. 39. How to do it? Please, anybody tell?
39 plus 1 by 39 plus 1 by.
So ekadhikano purveno. First like digit divisor. What?
Divide by
Digit
4.
divisor. Don't use any formula. Better to use what? Ekadhikano purveno. Purveno is 3. This 3 plus 1 is 4. I have to divide by 4. Okay. That means 7 by 39 will be equal to how much? 0. You divide 7 by 4. 7 by 4 is what?
1 and 3 balance.
1 and
1
3.
and 3. Yes. Then again this one by 4.
3 and 1.
31 divide by
31.
4.
Oh,
4.
4 and 3.
Huh?
4
Divide by
7
4.
20.
4 and 3.
4 and 3.
7 and 3. 7
7.
and 3, sir. 31, 7 and 3.
Yeah, exactly. 7 and 3.
37, 9 and 1. 9 and 1.
1.
19, 4 and 3.
4 and 3.
3. For 34, 8 and 2.
8 and 2.
28, 4, 7 and
0.
remainder is 0.
0. 1 and 0. 4. 3.
1 and 3.
Huh?
1 and
1
3.
and 3.
1 and 3.
31 again.
So,
7 and
so it
No,
will,
no.
that means
Repeat.
it is repeating. And you put
yes, sir.
a dot here and put a dot here. It has only 6. Length is only 6. So here also very peculiar. Here we cannot evaluate all the fractions here. What fractions we can do? With this cycle, what fractions are we can do? We see we can do 31, we can know 37, we can know 19, we can know 34, 28, and 7. For other things, I have to do different. It will be say 5 by 39 for dwarf. It is not here. So 5 by 39 again you have to do separately. So 5 by 39 will be equal to 0.5 divided by 4. That means 1 and 1.
1 and 1.
1 and
1
1.
and 1.
Yeah. Then 2 and
11,
2 and 1.
2 and 3.
3.
2 and 3.
32, 8.
8.
8 and 0.
8 and 0.
Then
2.
2 and 0.
2 and 0.
2 and 0.
Mm.
0.
0, put it 0. 5 and 0.
No, 0 and 2.
20, 4 5s are 20. 5 and 0. Remainder 0. 5, 1 and 1.
Back to starting, repeat.
Mm.
Okay. Now here also you can 6 length. Here also you can do only 11, 32, 8, 2, 20, and 5. Here. Now see another peculiar one. You do say 3 by 39.
3 by 39 equal 3 by 4. 1 and 1.
1 and 1.
3 and 2.
No, 3 by 4. 3 by 1 and not 1 by 1. 1 and 1.
3 by 4 equal to 1. 1 and
0.
1, sir.
No, 0,
0 and 3.
0 and 3.
3 divided by 4. 0 quotient, 3 remainder.
7.
30.
30,
7 and 2.
7 and 2. How is it taken, sir? 0 and 3. 3 by 4 equal to?
3 by 4, if you do anything you divide which is less than the divisor, quotient becomes 0.
Okay, sir.
Quotient becomes 0 because 1 cannot go. It has to be more than that, no?
Okay, sir.
They are not equal. So 27 becomes by 4.
9.
6 and 3.
6 and 3.
9 and 0.
900.
2 and 1.
2 and 1.
3. 3 and remainder 0.
3 and remainder 0. Then
same 0.
exactly. So these are 6 length. It always remains 6. This is actually 3 by 39 is 1 by 3 actually. Sorry, 1 by 13. 1 by 13 you have to do. So you cannot with the second digit, unit digit 3 cannot do. So multiply both things by 3 and then make 3 by 39 and then 1 by 13. You can do like this. Now you do another one. 13 by 30. 13 by 39. I will do 13 by 39.
13 by 4.
13 by 4 is 13 by 4 is how much?
4 and 1.
3 and 1.
13 by 4 is
3 and 1. Yeah.
Sir, excuse me, sir. No. Sir, shall I ask, sir? That the 3 by 13 is equal to 1 by 3 by 39 is equal to 1 by 13. See, now can we do this 1 by 13 in this model?
Yeah.
Yes,
1 by 13 has to be done by this model. And here see, you get is 30 by, this is 30 by 39. That means it is actually 10 by 13. This is 9 by 13. This is 36 by 39. It is 11 by 12 by 13. Here it is 3 by 13, 9 by 3 by 13. It is 4 by 13.
1 by 13, sir, now. 1 by 13.
So half of the things in the 13 you get this one, and another half you get. Say 2 by 13 will be from another cycle. 6 is not here, no.
Shall we do, sir, in this one 1 by 13?
Now 13 by 39. What is the question then?
No.
13 by 39.
13 by 4.
4. But for 1 by
13
13.
by 4.
13 by 39. 13 you have to divide by 4.
0.3
3
and 1, sir.
3 and 1, isn't it?
Okay.
3 and 1.
Again 3 and 1.
It's recurring.
Again 3 and 1.
13. So 13 by 39. Why it is the mystery is like this? 13 by 39 actually 1 by 3.
1 by 3.
1 by 3 is 0.333. Same thing will happen if we do 26 by 39. You will find that
0.6666.
0.666. Okay. So it will be also is equal to 2 by 3. So obviously by this method also you'll get like that. Now I come back to this thing. What is the now? Okay, somebody Parthula. Okay. Algebraic proof of bridging one-line method. Now, how many people? Some people will be interested in algebra. Some actually, Chalachiti Babu, he actually told me that not to discuss much. But nevertheless, I asked that is not actually a magic. This thing is working. Basic one-line method. This I did for 59. In one line, you are getting the answer of 1 by 29 and 1 by 19. Something by 19, something by 29. It's not a magic actually. What is the procedure? This was known by people for ages. This this mathematical may not be ages, but for some hundreds years. But we never they understood that these procedures have been already used in Vedic mathematics in evaluating this recurring decimal. You see, this thing like that. We have read on our college days the expansion of 1 minus x to the power minus 1. It is binomial expansion. But we never thought that this can be applied for using, for calculating recurring decimal. This is very peculiar. But so much treasure of knowledge is there somewhere, and people are not using it. They are getting confined into one procedure of multiplication, division, addition, subtraction. So it is like this: 1 minus x to the power minus 1 actually is 1 plus x. Binomial expansion, you know, isn't it? You know that a plus b whole square is equal
Yes,
to
sir.
a
A
square.
square plus b square plus 2ab.
A square plus 2ab. Normally we write in this format, either increasing order of these powers or decreasing order. So do not write a square plus b square plus 2ab, but a square plus ab plus b square. So if we do it like 1 plus x, I'm sorry, my charge is going on. 1 plus x square. You tell me what should be done. What is the thing? Is equal to, start with 1.
Whole
Okay.
square. 1 plus
So
x
1
square.
plus,
X square.
no, that not that way. Increasing order of power of x. So you write 1 plus 2x, isn't it?
2x.
Plus x square. Isn't it?
Plus x square.
So, but when it becomes negative, perpendicular, it becomes an endless power, which if it is x is less than 1. It is very important. With x more than 1, you cannot do it. X less than 1, x must be less than 1. Then only this formula will be work. It gradually it will be a converging one, actually. 1 minus x to the power minus 1. It will be 1 by 1 minus x. It will be less than 1, obviously. So 1, it will be more than 1, but it is converging. 1 plus x square plus x cube x. Gradually, actually, x is less than 1. So gradually, this number should be smaller and smaller and smaller and so on. And now you can take common. So it becomes 1 plus x bracket 1 plus x bracket 1 plus x. It will be endless bracket and bracket it will go for x less than 1. Now 1 by 29, 1 by 19, 1 by 29, 1 by a9, anything can be expressed as 1 by 10n minus 1. Now this 1 by 10n minus 1, 1 by 10n we take common, said 1 minus 1 by 10n, this thing less than 1, and which is to the 1 minus 1. So you get like this. Actually, more clearly I put here. Here we put. Oh, sorry. 1 by 10 minus 1. See, it can be this 10n. N is 1, 2, 3 you put, so that it becomes 2 you put. Here is 9 is separate case. 9 we didn't discuss. 9 also is same thing, but different, a little different also. But easy actually. 1 by 9 becomes easier, so do not discuss. So we take n is equal to 2, 3, 4, and so on, 19, 29, and 39, etc. Now it becomes 1 by 10n into 1 by 1 minus 10n. So 1 by 10n, 1 by 1 minus 10n to the power minus 1. Now, since it is getting minus to the power minus 1, this is separately done, and this is separately are putting 1 plus 1 by 10n plus 1 by 10n square. It is now my x is this. X to the 1 minus x is this. 1 minus x to the power minus 1. Same thing we did earlier. So it becomes like this. And then 1 by 10n common, 1 by 10n, 1 by 10n like this. That means instead of 19, we are dividing by 20. In case of 19, we are keeping on dividing by 20 according to this, and always not exactly, we do not satisfy at any point. Basically, when I am telling you that, I told you that to divide by 2, actually you are dividing by 20 minded, because we are throwing it to the next decimal point. So basically 1 by 20 we are dividing, and it is something more. So again we are doing with quotient and remainder, another one term here, another term. It goes on endlessly unless it is we stop. We need not have stopped. We stop, it will go to infinity, but we stop at, we know that it is recurring, so we put a dot and we stop there. So similarly for m by, my thing is blocking here. For anything m by, like say for example here, it is for say 7 by 19. Like example, 7 by 19 here. So m here is 7 and 2, n is 2 here in this case of 19. So 7 by 19 also simply put started with 7 and we did that quotient remainder, and finally all the different terms have been put in here. So this is the algebraic expression, algebraic explanation of the Vedic one-line method. Now, I have already shown in case of 13. Now I put for denominators ending in 1, 3 or 7. Now, was it clear? This one? Anyone? The algebra? Anyway, if anything, if later you can react also, if this is actually a matter of algebra, so may not be always relevant to consider, but we know that in background this thing is happening. And now I come to other denominators. So far we have done with n by a9. So here also I've shown that Excel sheet I put one, the a9. See, 9 is there always in the last. So what to do it is not 9. 1, 3 and 7. We have to multiply both numerator and denominator by 9, 3 and 7 respectively. So 1 into 9, ending into 1 into 9 becomes 9, 3 into 3 becomes 9, and 7 into 7 becomes 7 into 7 ends in 9, 49 ends in 9. Respectively, to get a denominator ending in 9. Anything ending in say 3, we multiply by 3, it will end in 9, following the same procedure. So 1 by 7 becomes 7 by 49. So we multiply both numerator and denominator by 7. So 7 by 49. We start with 7 and divide by 5. So 7 divided by 5 this way is 1 quotient, 2 remainder. Again 4 quotient, 1 remainder, 2 quotient, 1 remainder. So we get this. So 1 by 7 is 0.142857. 1 by 7 is 0.142857. Okay, this one. This one. Similarly, 1 by 13, I already put it. 3 by 39. So 3 by 4. So it becomes 0.0. I've already done it. In the blank screen, we did already 0.076923. We got it now earlier. We got it 30, then 7 and 2, 27. Then again 4, 6 and 3, 9 and 0, 2. This we got already. Everything divided by 4. So we got it. Now 1 by 17 becomes 7 by 119. So start with 7 and divide by 12. Start with 7 and divide by 12. So we got like this. Okay. See this one. So it is 1 by 17 has 16 digits. These are actually should be slightly towards left. This has to be set little. Anyway, I'll do it later. It is actually not below. It is actually slightly below left. So that is 7 is 0 is quotient, 7 as remainder, 5 quotient, 10 remainder, 8 quotient, 9 remainder, 8 quotient, 2 remainder, and so on. So 0.05888 up to 7 becomes 1 by 17. Now, concept of single and multiple cycles. For some denominators, we get a full single recurring cycle of cycle length d minus 1, the denominator minus 1. In case of 19, it is d is 19, 29, 59 cycles length are 18, 28, and 58 respectively. However, in many cases, multiple cycles with lesser length. For example, for d is equal to 39. Actually, 39 is a composite number. Mind it, these are all prime numbers. You understand prime and composite? Anybody? Everyone? So nothing can be, there is no divisor for this except 1 and itself. So that is prime number. So but 39 is divisible by 3 and 13 both. So it is actually it will have 6 cycles of length 6 each for n mod 3 0 and with but 2 with length 1 n mod 3 0 0. So 13 by 39 and 26 by 39 2 by 3. So therefore actually this becomes the 6 of cycles 6 into 6 plus this 2 is equal to 38. So this is again what? This d minus 1. You got it full cycle, but wherever you are getting some multiple cycle, in case of 39, it is cycle of 6 are coming, but there will be 6 different cycles of 6. So 6 into 6 plus this 2 becomes 38. It will be full cycle, can be explained that way. Similarly, for d is equal to 49, there will be one cycle of length to 42, for where it is not divisible by 7, and another of length 7 for this n divided by 7. It is to 1 by 7 to 6 by 7. So this will be 6 and 42. Again 42 plus this 42 plus length 7. Oh, I'm sorry. This is not length 7. This is length 6. Correct it immediately. 6. So length 6. I should have. Yeah, I made a mistake actually. So correct it. So for 49, there will be one cycle with length 42 and another with length 6 for n mod is 7 is 0. The 1 by 7 to 6 by 7. There will be 6 different things, and all are 6 length, and this and are used for the derivative is 7 by 1 by 7 to this thing. So 7 by this thing actually the 1 by 17, 1 by 7 and 1 by 13 this way. Correct. So again 42 plus 6 is 48, which is 1 less than this. Now small time is there, I think. Basic one-line method.
Sir, in this before slide 7 by 119 is came na? That is changed to 7 divided by 12.
Yeah.
Once repeat, sir, what is the answer? 7 by 12 equal to?
I'll tell you. I will slightly shift it also. Let me see whether I can do it. This one, this particular thing, I left. I shift it left. I increase it. That's okay. That way you can do later. Yes, I shifted slightly, so you can now see slightly left shifted. What are you telling? This 119 divided by 7 by 119. No. No.
Yes, sir.
7 by 119. So 1 by it will result in 1
that
by
is changed to 7 by 12.
7 by 12. So 0 and 7. So we divide 7 by 12. So it becomes 0 my quotient and 7 my remainder.
7.
It becomes 70.
70.
So
12 5s are
12 5s are 60.
And 10 is a remainder.
10 is remainder. So it becomes 105.
5.
105.
12 8s are 96 and 9 is remainder.
Exactly. Now it is 98.
12 8s are 96, 2 is remainder.
Exactly.
And 12 2s are 24, 4 is remainder.
Beautiful, very good. Now,
42, 12 threes are 36, remainder is 6.
yes, yes.
That is continuously repetition, sir. 63 means 12 fives are 60 and 3 is remainder.
Exactly. Yes.
And 35 is 12 twos are 24 and 11 is remainder.
Exactly.
112 is came. 12 nines are 108 and 3 is remainder.
Yes. 4 is remainder, yes.
39, 12 threes are 36 and 3 is remainder. Next 33, 12 twos are 24 and 9 is remainder. 33 is came. 12, 24 and 12 twos are 24, 9 is remainder. 92, 12 sevens are 84 and 8 is remainder. Hello? Sir, my voice is audible?
Yeah, but some after that 2 and 11, you got 9 quotient, 9 quotient and 4 remainder.
Quotient 3.
49.
Quotient 3.
49. 49, you got 4 as quotient and 1 as remainder. No.
No, sir. 2 and 11 means 112.
9, 12, and 4, not 3. 4 was remainder. See, 112.
Okay.
Slight mistake was there.
12 fours are 48 and 1 is
Therefore,
remainder.
you are getting different numbers. If you commit mistake in any level, all the subsequent will be actually wrong.
Okay, sir. Okay.
So this is this thing. It is already put here in the slide. Now, let me just beginning. We begin this one, and then I will leave.
Sir,
Like this.
Sir, excuse me, sir.
I just put a beginning. Yes.
Sir, shall I ask one question, sir?
Yeah.
Sir, please go to the previous slide, sir. Again, still more. One more slide, please.
Oh, sorry. Yes. Previous.
That is 7 by 5 is there, sir. 7 by 5. Here, the 7 by 5, because the denominator is lower than the numerator, then it should come 1 point something, not for 0 point. 7 by 5.
No, 7. No. 7 divided by 5. Not this. Actually, you're doing 7 by 49. 7 by 49. Okay.
It is 7 by 49,
dividing
not by 7
in
by
the quotient and remainder. You are not doing 7 divided by this notation I am putting with arrow. It is not. It is quotient and remainder. Not this. When I divide 7 by 5, my quotient becomes 1 and 2 as remainder.
Okay, it's not 7 by 5. It is 7 by 49.
7 by 49. This I didn't tell equal to. I put arrow. This is the procedure. This slash I am putting for division, and this dividing symbol with arrow means that's quotient and remainder format. That's what I'm doing.
Okay, sir. Thank you.
Not actually that way. Now let me start this thing, small thing. See, what is the difficulty we face when we divide something with ending in 1? We have to multiply both the numerator and denominator by 9. So instead of 1 by 29, 1 by 21, if you want to do, or something by 21, we have to do it by 9 or something by 189. Say 9 or 18, 27 by 189. And digit divider becomes 18 plus 119. We wanted to avoid division by 21 to arrive at wanted to do divide by 21, but we ended up dividing by 19. It is not dividing by 31. We will be doing by 28. In dividing by 41, we do by 37. So that way, basic one-line method in that format will not work properly. but it will not give me any relaxation. We consider that 1 by 21, 1 by 31 and 41 are of the form 1 by 10n plus 1. So that means binomial expansion of 1 plus x to the power minus 1, where x is less than 1, is 1 minus x, alternate. Earlier everything was plus, here now alternate 1 minus x plus x square minus x cube plus x square. It becomes 1 minus x, all minus x. So if we expand it like this, so these are 21, 31 and 41 and so on. So which is 1 by 19, 1 plus 1 by 1 plus 1 by 9, 1 by 10 and 1 by 10 and minus 1. So to the 1 by 10n taken out, 1 minus 1 by 10n plus 1 by 10n square minus 1 by 10n cube. So everything, suppose 1 by 10n is taken out, then bracket 1 minus 1 by 10n, 1 by 10 is taken out, like this one. And similarly, m by something by, say 9 by 20, say 9 by 31 or something like that. It will be m is 9. So, and 3, n is 3 here. So it is like this, so it will be again like this. So here we tomorrow we will be discussing this one, and we'll be discussing that way, but there'll be both ways you can do it, either by very difficult method 9 by 129 or by 1 by 21 directly with some hinges. This minus 1 vinculum will start come. And I have given a simple example without any vinculum. Tomorrow we'll discuss this 14 by 41. So we'll do how to do it. What is the meaning of this? How you are getting negative. Instead of adding the 10 times 10 r plus q, we do 10 r minus q. So this immediately will convert this thing as vinculum. 2 and minus 3 becomes 17. We work with 17 and do it. So you just go through the slide. You try to understand tomorrow, so that tomorrow explaining it will be easier. So I end here today. Namaskar.
Thanks, Andy. Dhanyavadamulu. Gautham ji. Now,
Yeah, I exceeded 4 minutes. Yes.
I stop the
Sharing. Yes.
sharing. Thank you so much.
Namaskar.
And also, Anjaliki, Dhanyavadamulu, all participants for active participation.
Exactly. That is what is important.
So now, shall we go for Prarthana?
Yes.
Yeah, we should go for Pradhana.
Wait.
Abhyah paripalayantam nyayena modyena mahim mahisa go brahmanebhyah subhamastu kale varshatu parjanyah vivisasya salini desoyam shobharahito brahmanas santu nirbhayah aputrah putrinas santu pautrinah adanas sadanas santu jivantu saradam satam satyam vada dharmam chara swadhyayan ma pramadah om matrudevo bhava pitrudevo bhava acharya devo bhava atidhi devo bhava om sarve bhavantu sukhinah sarve santu niramayah sarve bhadrani pasyantu ma kaschid dukkha bhag bhavet om shanti 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 om Purnamada Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Vasishyate Om Shanti 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 सर्वे जना सुखिनो भवन्तु स्वस्ति
ధన్యవాదములండి పని ప్రవీణ్ గారు. Now let us recite national anthem.
जनगण मन अधिनायक जय
जय
हे
हे
भारत भाग्य
भाग्य
विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद.
జై హింద్. ధన్యవాదములండి చిల్లా చిట్టుబాబు గారు.
నమస్కారం.